بسم الله الرحمن الرحيم رب زدني علما.
So now the next thing we'll move on and talk about the DHCP troubleshooting for IP version 4. Again, the prerequisite for this is I expect you to already know the DHCP configurations commands, like how the DHCP configuration is done, whether if you're using a router. And also we need to make sure that we verify these labs, and also the configuration with the relay agent and with the VLAN. So there are a couple of labs we did already in the section, in the configuration section. We already discussed these things. So here we'll try to see what are the possible issues with the troubleshooting and what are the things we need to check. So as I said, the prerequisite, make sure that you know the complete set of configuration and the commands you have to do, and make sure that you also verify the labs to ensure that you know the correct configurations with the DHCP. But the second thing is we need to make sure now let's say you started troubleshooting the DHCP, and probably in the production network you have an issue, or you realize that there might be some issue with the DHCP server. So before you go ahead with the troubleshooting, we need to make sure that we understand the topology, where are your DHCP clients are connected, in which VLAN it is or which LAN it is, and where exactly your DHCP server, whether it is on the same network or on a different subnet. So now this kind of basic information we need to have in order to troubleshoot. Like we already discussed in the basic troubleshooting, you need to know your topology, you need to know the configurations, you need to understand your topology and the configurations as well. So I expect you to know that. Now, one of the major issue or the common issue will be the misconfiguration. So if you don't configure the things properly, like whenever you do the configurations, we do exclude some of the addresses. And then under the DHCP pool, we have to configure the subnet with the proper network ID and the subnet mask. And then the default router or the DNS, these informations has to be correctly configured. So we can either use a showrun command or we can use showrun section DHCP to verify the configurations. So again, before you again jump into the any kind of DHCP configurations, we ensure that we do have a layer 1 and a layer 2 is working fine. So which basically means that let's say if I assume this is my DHCP server, I'm going to assume that the layer 1, the connectivity is fine, and we need to make sure that the VLANs, whatever the VLANs and the trunk links, all those things are working fine. Okay, so that is a kind of a prerequisite you have to check before you jump in. If you see any VLAN related issues, probably you need to get into the VLAN troubleshooting. So in our case, we are going to assume the layer 1 and the layer 2 connectivity is fine. So most of the time you report that when the user is unable to get the IP, we generally start with ipconfig/all, where you will see the IP address will be from 169.254 format. Now this is what we call it as APIPA range, automatic private IP addressing. So whenever the user or the device is selected to get an IP dynamically, and if it is unable to get, so it's going to automatically assign this subnet. So which basically means that there is a problem. So the first possible issue is the misconfiguration part. Like I said, the layer 1, layer 2 connectivity is fine. This is in a proper VLAN, and the trunk links, everything is working fine here. Also make sure that you have a port fast and all those things enabled. Now, the other possible reason can be, now again, you need to jump into the layer 1 connectivity and the layer 2. These are the two things we need to check. So let's assume that we do have the DHCP client is connecting to a switch, and we have a DHCP server somewhere connected here. And assuming that they both are in the same VLAN 20. Now we need to make sure that when this client sends out a broadcast request, it has to reach the DHCP server. And that is only possible if they are in the same VLAN, and assuming that we do have a proper layer 1 and the layer 2 connectivity is working fine. And also make sure that you have enabled the port fast so that there is no more listening and learning states, and the port goes to forwarding immediately. And in between, if you have multiple switches, again, you have to verify the trunking and all those things. So we assume that the layer 1 and the layer 2 connectivity is fine. And if the DHCP server is on a different subnet, like here we have a client, and this client is connecting to a switch and then to router. And from there, we have a DHCP server on a different subnet. So we need to make sure that whatever the broadcast request which is being sent by this DHCP, basically the offer message, the discover message, and it has to be sent as a unicast by the router. So we configure IP helper address command. That configuration command should be present on the router in a correct interface, and the correct IP address has to be configured. So the other thing we need to check, if they are on a different subnet, then make sure that the router is sending the broadcast request, assuming that the DHCP server is on a different network or different VLAN. Now, the other possibilities are like the DHCP pool might out of IP addresses. Like, let's say I have configured a pool of 250/24 here. So which means the address range will be 0 to 255. And the maximum addresses I can allocate is 254. So which means already the DHCP have assigned all the 254 addresses to all the devices. And there is no more IP address left over to assign. So normally when you have configured the subnet with a limited number of addresses, and that pool, if it is depleted, in that case, there will be no new addresses, no more IPs to assign, which means any new DHCP request will be automatically rejected. Now, most of the time when we design the subnets, we make sure that whenever we are doing the configuration for the DHCP, we configure in such a way that if your requirement is around, let's say 60, we just go with some higher size, let's say 128 size. Or if your requirement is, let's say 100, we go something higher. So normally that is, again, the best practice while you do that. And let's say maybe due to the misconfigurations that can lead, I mean, sometimes again, you might have misconfigured the subnet. Instead of /24, you might have configured /27. That might be the case. Or the other possibility is even there is something called a MAC flooding attack, where attacker, sometimes, you have an attacker who is going to send out a request with a fake MAC addresses and then send out a continuous DHCP request on one port with a different MAC addresses, which means now the DHCP server is going to listen to those messages and then respond back with an IP. And like that, the existing IPs all the IPs will be depleted in that case. So when a valid user is requesting for an IP, it says, I don't have enough IP addresses. Now, to overcome this, again, there is a concept called port security. That's something you will see in the security concept, the layer 2 security. Of course, if you have implemented port security, that is a solution to prevent this kind of attack. But again, when you are designing or when you are configuring the pool, make sure that you are configuring the appropriate pool with the number of IPs or available, which are more than what the number of IPs what you exactly require. So this is another possible reason that might be the case where the end users might not be getting an IP address because of the lesser or the fewer IPs available on the DHCP. Now, the other possibilities, like you have some duplication of the IP addresses. Now, the duplication of IP addresses normally happen when you have a server, let's say, and I have assigned the IP address of 192.168.1.5 to the server. And also we have a DHCP server, which is configured with assigning the IP address of 192.168.1.subnet. Now, normally what we do is we generally exclude this address of 1.5, whichever the IP assigned static IPs, whatever the static IPs you give for the router, for switch, or for any servers, we generally prefer to exclude. And in case if you do not exclude that address, then there is a possibility that another client may end up getting the same IP. Now, in that scenarios, this device will not be able to have reachability to any other devices, and that is because of the duplicate IP address. So these conflicts we can verify with a command called show IP DHCP conflict. So it's going to show you what is the IP which is conflicting, and it is going to use some method called ping method, and then it is going to detect that. And then you can verify the same thing with the show IP DHCP binding, and you can also verify the binding as well. So you can clear that bindings and make sure that you exclude that address, whichever the IP you are using as a static. Now, the other possibilities are like the interfaces are not configured with the IP address DHCP pool. Now, this is with respect to our this example will consider here. Like there is a possibility that the SVI interface, let's say this is my SVI, where you have a client and the client is sending a broadcast request on this interface, and will configure some IP helper address here. And this IP helper address is going to send out a unique hash message to the DHCP. And if any of this interface, whether any of the interface which is reaching towards the DHCP server, if there is no IP address, like in this case, this SVI, or the DHCP client broadcast request received on this interface, if that interface is not configured with the IP or a different IP subnet, that can also be an issue as well. So at the end, it's all these all things lead to the correct configurations which we have to do. And the other possibilities are like the redundant services not communicating. Now, redundant services means now you can have a multiple DHCP servers set up in your network for the sake of redundancy, and both the DHCP servers will be responding to the request, and any one of the DHCP server is going to assign the IPs. And let's say whatever the IPs it has assigned, it is going to sync with the other DHCP server to ensure that the other DHCP server is not assigning the same IPs. So there is a synchronization of the database or the information which is being shared by redundant servers. So due to some reason, if this is unable to sync due to some connectivity issue, in that scenarios, there is a possibility that whatever the IPs which are being already allocated, and the DHCP server 2 is not aware of that, it may end up assigning the same IP to some other users. That can again lead to the network reachability issues. So most of the time when you have a duplication of the IPs, those users will not be able to communicate because of the duplication of the IPs. Now, finally, there is one more thing we need to know, like DHCP snooping. Now, with respect to the DHCP snooping, like the DHCP snooping, I'll give a quick overview. But again, the DHCP snooping is a feature you will see in the layer 2 security. Now, this is basically to prevent any unauthorized DHCP servers. So whichever the ports connecting to a DHCP, we configure them as a trust, and they will be sending out the offer messages on the DHCP, and all the remaining clients, these ports we configure as an untrusted port. So we need to make sure that all the trunk links and the ports facing to the DHCP server configure as a trusted ports. Now, due to some reason, if you move the DHCP server to a different port, or maybe you have added another DHCP server, and that particular port, if it is not configured as a trusted, then the switch is going to drop those offer messages, because the offer messages are only sent over the trusted ports. So we need to verify that configuration by using show IP DHCP snooping. Also, you have to check any issue with that.